Welcome to this explainer. Today, we are unraveling the complex, high-stakes world of effluent quality management. We'll be looking through the lens of the SASB water utility standard to figure out exactly what happens to the water leaving a treatment facility, and honestly, why getting it wrong can be absolutely catastrophic.
So, let's dive right in with a simple but maybe slightly alarming question about the everyday products we all use. What actually happens to the chemicals you wash down the drain? You know, when you rinse off a lotion or your washing machine empties, where does all that invisible chemistry actually go? Well, the answer is a lot more complicated and way more critical to our health than you might think.
To uncover that answer, we'll follow a quick roadmap. We're going to look at the hidden water threat, meet the emerging contaminants, look at the steep costs of non-compliance, check out strategies for safer water, and finally, look at how we track utility performance.
Starting with Part 1, the hidden water threat and navigating the wastewater journey.
Okay, so it all starts with this term, effluent. Basically, this is the treated liquid that re-enters our environment and our groundwater supply. As the SSB standard defines it, effluent includes all the residuals, solids, chemicals, and contaminants that are left over from the treatment process, which then get discharged back into surface water or groundwater.
And if that treatment process fails, well, the environmental and human health impacts are devastating. We aren't just talking about natural waste here. We're talking about complex chemical residuals that can severely damage the ecosystems and the water supplies that you and I rely on every single day.
Which brings us to Part 2. Meet the emerging contaminants, the invisible threat.
These affluents of emerging concern come straight from our daily lives. Think about pharmaceutical residues, personal care products, flame retardants, detergents, and hormones. These substances are completely invisible, yet they carry this massive potential to disrupt environmental stability and human health. A major one to watch here are endocrine-disrupting chemicals, or EDCs, which can literally interfere with our body's natural hormones.
The SASB standard points this out very clearly, noting that consumers and regulators are becoming increasingly concerned by substances that might not even be treated by standard wastewater facilities. I mean, people want to know their water is safe from modern chemical residues. And that's putting utilities under intense public scrutiny to somehow capture these highly complex substances.
So what happens when things go wrong? Part 3, the cost of non-compliance and the high stakes for utilities. When utilities fail to treat this water and end up exceeding their jurisdictional limits, the consequences are monumental. We're talking significant regulatory penalties, formal enforcement actions by governments, and really strict administrative and judicial orders. And on top of all that, they get hit with sharply increased operating costs and capital expenditures just to fix the massive failures.
But beyond the fines, utilities risk losing something called their social license to operate. Now, this isn't a physical piece of paper. It's the fundamental trust and consent of the community they serve. Losing that means facing intense public pushback and heavy political pressure. It's a total loss of trust that is incredibly hard to win back once it literally goes down the drain.
Let's move on to Part 4, strategies for safer water and how utilities are fighting back.
To manage these threats, utilities generally use two frameworks. Think of a hazard as a shark in the ocean, right? The risk is the actual likelihood that you are swimming with that shark. The hazard-based approach manages effluent based purely on its toxic traits, regardless of exposure. Meanwhile, the risk-based approach integrates that toxicity data with the actual probability and magnitude of exposure. And in reality, a lot of utilities will use a mix of both, depending on the specific threat.
To scrub the water of these invisible threats, like those microscopic hormone residues we talked about, utilities are investing in some heavy-duty technological firepower. We're talking highly engineered, advanced wastewater treatments, things like granular activated carbon, ozonation, advanced oxidation, and membrane treatment. It's some seriously impressive science. But, all that cutting-edge technology means absolutely nothing without a specialized human workforce running the systems day in and day out. Proper infrastructure planning, rigorous equipment maintenance, and deploying highly trained labor are absolutely vital to making sure these safety nets actually hold up. And finally, Part 5, tracking utility performance with the SASB standard.
Because environmental risks can so quickly become financial risks, investors demand accountability. The SASB framework lays out clear, standardized disclosure topics and metrics specifically targeting effluent quality management, so investors can see exactly how utilities are managing these threats.
Take metric, IF140B.1, for example. Utilities must disclose a hard quantitative number, exactly how many non-compliance incidents actually resulted in formal enforcement actions. It gives us a really transparent look at how often a utility failed safety standards and got caught by regulators.
Furthermore, the next metric requires a detailed qualitative discussion. Utilities have to transparently explain exactly how they plan to fight these invisible chemical threats. They detail their hazard or risk-based approaches, their investments in those advanced technologies, and how they monitor the risk of everyday contaminants becoming newly regulated down the line.
As we wrap up this explainer, I want you to look at your drain and ask yourself a critical question. Is your local utility actually prepared to safely treat the invisible, emerging chemicals in tomorrow's wastewater? The standards and the advanced technologies are out there, but with our health and ecosystems on the line, the stakes have truly never been higher. Thanks so much for joining me, and keep questioning the invisible systems that run our world.